Hi everybody. This video will show you how to use the MIT App Inventor 2 tool to create an app where you can control an object by changing the orientation of your phone. The first step is to create a new project, which we'll call Rollerball. And once that's created, we'll need to connect our phone using the AI companion tool that is hopefully already installed on your phone. If not, this step is very easy. And once that's connected, your phone is able to act as an emulator for whichever project you create. So the first step for creating any project where you want something to move around is to have a canvas on which it can move. We'll set the width to fill the parent so it takes up the full width of your phone, and for the height we'll go ahead with 300 pixels so we have some space at the bottom of the phone to add a few other features. Now that we've created that, we'll set the background color to a light gray so we can see the playing area for the game. What we'll need then is a ball that we can drag on, and this ball we'll go ahead and call the roller, since this will be the only object that is controlled by tilting or moving your phone. And then we're going to need to use the sensor, the orientation sensor, which is a non-visible object, and that will be what controls the phone. What controls the ball. We'll want to set the speed of the ball to 5 so it can move once it receives an update from the orientation sensor. Now, in order to control the ball, we'll use the orientation sensor and set actions to take place when the orientation is changed. Then we'll go to the roller and we'll want to adjust the heading of the roller whenever the orientation changes. So we'll pull that piece of the puzzle in and then use the orientation sensor angle as the control for the heading. Now this is a very simple game here, but at this point you should see on your phone that the black dot is able to move around, and whenever you change the orientation of your phone, the dot rolls with it. So that's the first step of the game. Now what we'll want is to create another ball that is going to be the point. So this means that you're going to be trying to roll the roller into another ball, which we'll call the point. So we'll put that onto the screen, rename it to avoid confusion, and change the color to, let's say, green. Now if you're on your phone, you can see that you can move the roller and it can collide with the point, but nothing happens. What we'll want to do now is make it so that when there's a collision between those two objects, we can update the score, which we'll have to add in as we go. So to do that, we'll set a control for when point is collided with. Since we'll be adding in more features later, we're going to want to check to make sure that the collision that's happening is between the ball and the point. To do this, we'll use the math equals puzzle piece. We'll pull that into the if statement, and then we'll want to hover over the other and then get other, and then we'll want to check to make sure that the collision object is in fact the roller. So when this statement is true, it will execute whatever is in the then statement. When the ball and the point collide, we want two things to happen. First, we want to add 1 point to the score, and second, we want the point to move to a new position, so we have to go after it there. To move the point to a new position, we'll click on the point in the blocks section, and we will call point move to. So this will mean that whenever this if statement is true, the point will move to these x and y coordinates. Because we want the point to be in a new position after each score, we will use the math function random integer to pull up new coordinates for both the x and the y positions. Now we don't want the point to be too close to the edge, so we'll set it to 10 pixels away from both the x and the y coordinates. Now the y coordinate is the height of the screen, which we already set to 300. So that means we can set it to about 290 to be 10 pixels from the edge of the bottom. Because the x coordinate is variable on the phone, we are going to need to use the canvas width function to determine what the actual width is going to be. You can find that by clicking on canvas and bringing it in. And now, because we don't want the point to be positioned right on the edge of the screen, we will use the math function subtraction to subtract 10 pixels from the total width. So now, whenever the roller and the point collide, the point will be moved to a new position. The next step we want is to add 1 point to our total score. To do this, we will need to create a global variable called score. What this function does is each time the game is loaded, it will initialize this variable and set it to whichever score we want. In this case, we want the score to start out each game as 0. So now that we have a score, what we'll want is to set that variable to a new value each time the ball and the point collide. To do this, we will use the math addition function, and we will use the score variable, and we will add 1 to it. So now, each time the ball and the point collide, we see a score go up by 1. We'll also want this to be displayed, and to do that we'll need to go back to the designer, create a label that can be controlled by the score variable. To do that, we will need a label, which we can rename to score. And we can set the initial text to 0. We'll go back to blocks, and now that we have that label score, we can set it to change the text as needed. And then we'll duplicate global score and set it to update the text of the score label to the global score each time a point is scored. Now when you go back to your game on your phone, you can see that whenever you collide the roller with the point, your score goes up by 1. In order to make this game a bit more complicated, we'll go ahead and add in an obstacle that, when it collides with the roller, causes you to lose the game. To do this, we will need to create an additional ball, which we'll drag on, and we'll go ahead and rename it to obstacle. And change the color to red. Now that we have an obstacle to avoid, we'll go into the blocks and set up what happens when the ball and the obstacle collide. So we'll go over to roller, and when roller collided with, and again we have the other, so we'll want to do the same if then that we did earlier. So if get other is equal to the obstacle, then we want certain things to happen. So what we want is we want for the ball to stop moving, so we'll set roller enabled to false. Now you can check your phone and see that when the black dot collides with the red dot, they freeze in place, and this signifies that the game is over. Now that we have a way for the game to end, we also need a way for the game to restart. To do this, we'll add a start button on the main page. We'll change the text of this button to start and rename it to start as well. We'll go over to the blocks and set what happens when the start button is clicked. So when the game ends, we can see that the roller is disabled. So what we'll also need to do then is duplicate and set it to re-enable the roller. If this is all we did, the problem is that the obstacle and the roller are still in contact. So as soon as you hit start, the game will immediately end again. To fix this, we will need to reposition the obstacle. We can do that by duplicating the random positioning that we use for the point each time it is moved. So we drag that in there, click it in place, and then change from point to obstacle. Additionally, we will want to reset the score variable to 0 to signify that we're starting a new game. To do that, we will go to Variables, Set Variable, select Global Score, and duplicate a number and set it to 0. In addition to doing this, we will also have to reset the score label to the new value of 0. You should see on your phone that by clicking Start, if you have a score, it's reset to 0 and the obstacle moves to a new position. We now have a working game where you can score points, you can lose, and you can restart the game. However, it is very simple and very easy to win, so we're going to add a level of difficulty. After scoring the first point, we want the obstacle to start moving, and we want it to get faster each time you score an additional point. On top of that, we're going to make it so that when the obstacle collides with a point, you lose a point, and you can lose the game if the obstacle reduces your score to 0. We'll do this one step at a time, starting with increasing the speed of the obstacle each time a point is scored. In order to change the speed of the obstacle, we'll need to go back up to the collision with a point. Each time we score a point, we want the obstacle to get slightly faster and to change its heading. To do this, we will need to adjust the obstacle speed by incrementing it by a small value. Depending on how difficult you want the game to be, you can set the speed to increase quickly or gradually as each point is scored. In this case, we'll use a speed of about 0.5. We can duplicate this addition, pull out the get score, and then we'll need to find the current obstacle speed, which always starts out as 0. Now we have the obstacle speed set to increase by 0.5 after each point is scored. We also want to change the obstacle heading so it can move in a different direction each time a point is scored. For this, we will want a random integer between 0 and 360 degrees. So we can duplicate this random block, bring it up to the heading, and change the numbers to 0 and 360. Another thing that we can do to make the game more challenging is make the obstacle bigger with each point that gets scored. To do this, we will change the obstacle radius, and we'll want it to increase by 1 pixel after each point is scored. Again, we'll need to duplicate the addition, bring it down. Trash that. So now we have the obstacle increasing in speed, changing its direction, and getting larger as each point is scored. Now that the obstacle is also in motion, we will need to set it so that when the roller and the obstacle collide, both objects stop. To do this, we will duplicate the set roller enabled and change roller to obstacle. This way, they both stop upon a collision. This also means that when we click the start button, we need to make sure that the obstacle is enabled. Otherwise, the fact that its speed increases will not cause it to start moving. So we'll duplicate this, bring it to the start click section, and change false to true. Now, clicking start will enable both objects for motion. If you're following along on the phone, you'll notice that whenever the obstacle runs into a wall, it doesn't bounce off. We will need to add this feature by using the obstacle bounce function. So when the obstacle reaches an edge, we'll want to call the obstacle bounce. Additionally, you will have noticed that even when you click start, the obstacle is at its larger size and it's already in motion at the beginning of the game. We'll need to change it so that the start button also resets the size and the speed and the heading of the obstacle. To do that, we can duplicate the set obstacle enabled and bring it down. Change enabled to radius, and then duplicate a number and set the radius to the initial size, which was 5. We can throw away the true, and then do the same thing to reset the speed to 0. And we can actually leave the heading alone because it will be randomized after the first contact. Now, going back to your game, you can see that clicking Start resets the size of the obstacle to 5 pixels and freezes it in a new position. The last gameplay feature that we want to add is what would happen in a collision between the point and the obstacle. As stated earlier, we want this to subtract 1 from the score, and we want to be able to see that if the score goes to 0, the game ends. So we will add an else statement to this point collision box, and we'll set it to check to see if the collision happens between the point and the obstacle. Rather than increasing the score by 1, we want the global score to be decreased by 1. To do this, we can either use the subtraction math function or just add -1. We will then want to update the score label, and we'll also want to count this as a point for the obstacle, so we'll keep the speed, size, and heading increasing and randomizing happening to keep the game exciting. Now, if you go back to your game on your phone, you should see that anytime the obstacle collides with the point, it subtracts 1 from your score, and it continues to increase in size and go faster. We also now want to add an endgame scenario if the score goes if the score goes to 0. So we will add another if statement. And in this if statement, we'll want to check to see if the global score is below 0, and if it is, we'll freeze both the obstacle and the roller. Now, whenever the global score goes below 1, it will disable the roller and it will disable the obstacle, meaning that the game has ended. One step I forgot is that we want to make sure that each time the obstacle and the point collide, the point continues to shift around the playing field. We'll do that by duplicating the above point movement and copying into the obstacle collision if statement. And because everyone loves keeping track of their high score, we'll go ahead and add one more feature here to do just that. We can copy the global score and we'll change it to high score. And that needs to be initialized to 0 at the beginning of each game. Then we're going to add a test at the end of a roller colliding with a point to see if the new global score is higher than the global high score. That's in the control section, and we'll do a while test. So what we're going to want to do is test to see if global score is greater than high score. And if it is, we'll increase the high score in addition to increasing the regular score. So while global score is greater than the high score, So when global score is greater than the current high score, we're going to set the high score to be equal to the global score. Now we'll need to go back to Designer and add another label where we can display this information. We'll rename this to high score and set the initial display to show 0. Now we can go ahead and make this look a little bit better by using the layout function. We'll add a horizontal arrangement under the start button, and then we'll put the regular score in there, and we can add another label to say what that score means. So we'll drag the label in, change the text for that label to be score. And now we can see what the score is, and we'll set another label for high score. And because these are just labels, we're not going to go bother renaming them. We'll add a layout again, horizontal arrangement. And in this horizontal arrangement, we'll put high score and the high score number. So now when you go back to your game, you'll see that you have a score and a high score being shown at the bottom. Now we just need to set the high score to be updated to 0 whenever a new high score is set. So we will duplicate this, bring it down, change score to the high score label, and change the number to the global high score. So now each time a high score is set, it will update on your screen. So now we have a game where you can control your ball to try and score points, and you have an obstacle that gets in your way and works against you the farther on in the game you get. I'm going to scroll through all of the code one time in case you missed any of the steps, and I hope you enjoyed watching this video. Thank you for your time.